huge aquariums in my house. He said, I have a saltwater aquarium and a freshwater aquarium. He said, I know that ocean water is about 3.6% salt. He said, I got curious many years ago. I wondered if I could mix all my fish together. He said, so I figured out the mathematics behind slowly increasing the salt in my freshwater aquarium. Because every few weeks you got to change the water, change half of the water every 2 weeks or something like that. So he did all the math on how to add salt to his freshwater and subtract salt from his saltwater aquarium. He did it very slowly so that it took him 10 years to make the change. After 10 years, both aquariums were 1.8% salt. All of the fish doing fine, and so he mixed them all together. Now, if somebody can do that in 10 years, going from 0 to 1.8% salt, do you think in 4,400 years the fish or animals could adapt to a salt change from 0 to 3.6%? Well, that's no problem. The evolutionists are great at straining out gnats and then swallowing camels. They will pick on one little detail they don't agree with on the creation account, like how did Noah fit all those animals on the boat? I said, well, I don't know. So I see, you couldn't be done. Just because I don't know doesn't mean it couldn't be done. Okay. Secondly, the fact that this is an unanswered question so far doesn't prove we all came from a rock. Strain out the gnat and swallow a camel. They're just really good at it. So the saltwater to freshwater change probably took place after the flood. And even today, there are huge salt domes underground that are leaking into the oceans. The ocean is gaining salt from all sorts of places. In Grand Saline, Texas, halfway from Longview to Dallas, the town called Grand Saline. Saline means salt. Years ago, it was discovered right on the surface of the ground there was pure salt. Animals would stop there and lick it all the time. So they began to dig it out and sell it. And they kept digging down and found out it's what's called a salt plume. It is absolutely enormous. There are hundreds and hundreds of people that work at this salt mine, if I understand it. Here's the surface of the ground. They had seen a little patch of salt right here. It turned out to be a massive salt plume. Apparently, from way down deep inside the earth, this was hot and bubbling, and it came up and solidified just before it popped out through the surface. It's pure salt. They dig into it with bulldozers and backhoes and everything else. I mean, it's gigantic. It's many miles across of solid, pure salt. Be a good thing for you to do, Eric, is to look up salt in the encyclopedia and just read, and you can see some of the pictures of this. And when they dig it out, of course, you can't just dig it all out because your roof falls in. So they will dig tunnels down and dig shafts off to the side. And even when they're digging off to the side, they can't dig a big area out because the roof falls in. If you looked at it from the top, they dig what's called a checkerboard pattern. They leave little squares of pillars to hold the roof up. And they dig out everything in between. And they've calculated, how hard is the salt, how much weight can it hold, and how big does our pillar have to be, et cetera, et cetera. They want to dig out the maximum without having it collapse on them. So they can only actually mine a certain percentage of it, maybe 40%, and the rest is wasted just as structural support. It's that way with any underground mine. They have to leave some material behind. So the salt in the ocean is not a problem for the creationists. Probably the oceans were largely freshwater at the time of the flood. There may have been some mixing of water. May have been some saltwater animals before the flood, maybe saltwater lakes like we have today. I don't know. But this is no problem we have to worry about. All right, let's take a little break. And when we come back, we'll discuss some more ways to show the Earth is not millions of years old. All right, let's continue now with some ways to show the Earth is not millions of years old. By the way, for the quiz next week, we will have, or whenever the next quiz is, we'll have one of the questions will be, what is the erosion rate of the Niagara River? And the rate is of the Niagara Falls. The rate is 4.7 feet a year is the current rate right now. What is the evolutionist's answer to why the Niagara River or gorge is only 7.5 miles long? What's their answer to that? Ice Age, right. Not proven, but interesting theory. Okay. When water drips through the ground, yes, sir.
There were any ice ages?
There certainly were at least one major ice age. A couple of theories about when it was. When ice melts back, when a glacier melts back, it leaves behind obvious signs, like piles of rock that it piles up called a drumlin or a kettle lake or terminal moraines. There's obvious glacial effects that are found all over Ohio, Michigan, Indiana, Illinois. No question, ice came clear down to Kansas City, Missouri. The question is, when did this happen? And we get into that quite a bit in video number 6 of my series on the Hovind theory about when was the ice age and all this kind of stuff. Okay, when water goes through the ground, it soaks through the ground. If it is on decaying plant material, when plants decay, it produces what's called carbonic acid. Carbonic acid is one of many, many different acids. It dissolves limestone. If you take boric acid or battery acid or muriatic acid, which is hydrochloric, the same stuff in your stomach, hydrochloric acid that digests your food, you can buy muriatic acid at the hardware store for $2 a gallon, and you pour it on concrete driveways. You'll see it foam and bubble, and if you leave it there long enough, it'll eat a hole through your driveway. It'll dissolve your concrete. Eats it right off. Well, slightly acidic water, the stronger the acid is, the faster it eats the rock, okay? Particularly limestone. Well, when it rains on the forest, the dead leaves and stuff laying there are going to decay and produce carbonic acid. This soaks into the ground, and so the water soaking through the ground is slightly acidic, which dissolves limestone. And that's what makes caves down in the ground, like Carlsbad Caverns and the major cave systems all over the world. Missouri alone, just that one state, has over 5,000 known caves. Plus, who knows how many, of course, that aren't known. But the caves are, many parts of the world contain caves, and Missouri, Arkansas has lots of them because there's just lots of limestone. So this acid dissolves the limestone. When it starts to drip, this water dripping containing the dissolved minerals, the air blows past, evaporates the water, and leaves the minerals behind, and it starts to leave a formation. In a cave, if it's hanging from the ceiling, it's called a stalactite, sticking tight to the ceiling. If it's sticking on the ground, it's called a stalagmite. If they join together, it's called a column. And if it just drips out of a long crack across the ceiling, it makes what's called a ribbon. As there's a long ribbon shaped like a piece of sun. And they have all kinds of fancy names for them when you go into the cave. They say, oh, this is the bacon formation, because it looked like a piece of bacon or something. Of course, they're trying to get your tourist dollars, is bottom line. But the fact is, caves are filling in with stalactites or stalagmites. Whether it's hanging on the ceiling or sitting on the floor or just making a big pile, it's called flow stone, because it's rock that was flowed into place, for lack of a better phrase. This picture shows Carlsbad Caverns in New Mexico, and it says, this unfinished symphony was started 250 million years ago. Now, how do they know that? Well, somebody measured how fast these things grow, and then they calculated it takes 1,000 years to grow an inch. And based on somebody's test that it takes 1,000 years to grow an inch, they measure how big this is in, Carlsbad Caverns and say, wow, this took 250 million years. Well, this is just plain not true. Those things grow very quickly. Here's a bat covered up with flowstone before he could even rot. National Geographic, 1953, October issue. Now, how long would it take a bat to rot after he died? A few days, a couple of weeks maybe at the most. In a cave where it's, dark and cool, he may last longer, maybe a month. But something else is going to eat him, right? Certainly not millions of years. We could agree with that, right? The decay rate may vary greatly depending on lots of factors, but it's certainly not millions of years. Most caves are about 55 degrees. Summer and winter, doesn't matter. It's about 55 degrees down in a cave. So the bat's not going to be refrigerated. It's not like a refrigerator. It is chilly, but it's not below